But like a 110.
Yeah, like 110.
It's an exponential. No,
No, not like that. It's just like that.
Oh.
Tell me where it crosses. Tell me where it crosses the y-axis. Tell me. Doesn't cross the y-axis.
Crosses that one.
So just like an asymptote, it goes towards them. Yeah, it goes across the y-axis at 1, I think. Yeah. So when x is 0, the y point's 1, definitely. It goes through here. So 2 to the power of 0 is 1. Okay. And then this is exponential. So it's exponential growth. If you ever hear about that in business, hopefully you have. That it's going to shoot off up from there. What does it do? What does it do on this side?
Just like very shallow.
Yeah, it approaches the x-axis. Does it ever cross the x-axis? I know that's pretty bad drawing.
It doesn't. That's actually so like y equals 0 would be one asymptote for this graph.
Y is equal to 0.
Y cannot equal 0.
Yeah, would be an asymptote. Yeah, it would approach it. It won't get there, and we discussed that. It'll never get negative. It'll never cross that line. Okay. What about the different one? Y is equal to 2 to the negative x. What would that look like on the same graph?
Log. Opposite.
Log.
Reflected.
Reflected.
Yes.
It would look reflected in the y-axis.
Not like that.
Y equals X.
Reflected in y equals x.
Negative X equals Y.
No,
that's
I
like
like this.
No, look.
Reflected in.
No, it's literally like this.
It's literally like this.
No, but like it shallows.
It shallows this way.
Reflected in y.
Oh, so it goes like this,
Yeah.
Yeah.
or does it go like this?
No.
No. No. Lexi, Charlie's. Hmm.
Can't be negative.
It can't be negative. Okay, yeah, so you could probably test the point. Is it going to cross at the same point here?
Yeah.
When x is 0, it's still going to give 0, yeah? And when x is a large negative number, so like negative 10, what's the y value going to be? When x is negative 10, so down here, what's the y value going to be?
2 to the power of 10.
It's going to be 2 to the power of 10, which is a pretty large number, yeah. And when x itself is a 10, positive 10, that would give 2 to the negative 10, which is 1 over 2 to the 10, which is quite a small number, fraction. Yeah.
If you would write that as like 2 over x, shouldn't
2 over x?
x never be 0?
2 over x? Right. Yeah, that's different. That's 2x negative 1. That's not the same as 2. Yeah, okay. Yeah. Correct in a way, but wrong. Okay. Let's look at a specific question then. Let's look, can we draw these? Whoa, don't look at that. That was cheating. Sketch the graph of 2 to the negative x minus 3. So we have 2 to the negative x here in red. That's y is equal to 2 to the negative x. What would 2 to the negative x minus 3 look like?
Whole graph should
Down.
Yes.
Bring it down.
Yes. Where would it cross the y-axis? Negative 2, yeah. 1, and then negative 2. It would go down 3 from where it was. Go down 3. That's 3 units down. 1, 2, 3. I know, the scale is way off. Very good. Okay. There's some transformations. We're not going to get too much detail about them. They're, in general, you know them, I think. What happens if we, well, maybe you don't. They look a bit complicated here. If we take the general form of this exponential equation, so some number could be multiplied by the a. Let's use the same letters that they have over here. What does each one do? You knew what the k one did. You knew that the k, an addition or a subtraction will move it up and down. That's a vertical or horizontal translation. So that's the vertical translation. You knew that automatically. You were able to go there. What happens when we have a multiplier in front? So this p. Yeah, you can see you can do a bunch of things. Yeah. Depends on if A is a fraction or not. If A is fraction, and if P is positive or negative. If P is negative, it'll turn it down. If P is positive, it'll turn it up. Yeah, you see what I mean. So if P is greater than 0, it'll go this way. If P is less than 0, it'll flick it down like that. So it will just change the shape. It's probably better drawn there. And the H still controls the horizontal translation. How would that look? This H. So if it's in with the X, it is the horizontal translation. And maybe we can just look at that. So we have in blue, we have Y's, in black here, we have, this is Y is equal to 2 to the X. What would happen if I did Y is equal to X plus 3? What would that graph look like? Good. The y-intercept would be different? I think so, yeah. Well, what would the y-intercept be? So when x is 0 would be the y-intercept, yeah? So if this is my function, when x is 0, we end up with 0 plus 3. Y is equal to 2 to the 8. So the new...
2 to the 3, which is...
Oh, 2 to the 8, which is 3, sorry.
2 to the 8, which is 3. 2 to the 3.
2 to the 3, which is 8. That's all right. I was going to have coffee and then I didn't. So it now crosses here. Now, is that a shift to the left or to the right? I think Derek has it already. It's to the right.
To the left. Because, look at it. It's a black one.
It got there earlier, didn't it?
Oh, we're talking about the black line, yeah.
Yeah, so this one used to be here and now it's gone that way.
It's gone, shift to the left.
So that's, remember, so we're drawing, so it's going to have the same shape, something like that. So that is 2 to the x plus 3. I use 3, yeah. So a plus gets there earlier, so it just looks like it's shifted to the left. So same as what you did in GCSE, if you remember it. We didn't really do too much of it, but an addition to the x will get there earlier, which means that earlier is more to the left in maths. So you read things from left to right in addition. Okay, let's look at, did I do that question? Oh yes, the final thing. What is the domain and range then? So there's a lot going on the board here. Let's just tidy it up. Well, so we have this new function, y is equal to 2 to the negative x minus 3. And I want to know the domain and the range. What's the domain? What's the x values? Yeah. X values are input values, and the range is then the y values. All possible y values are output values. Okay, so what's the domain of this function? What is...
X is all real, all positive.
So I've drawn it here. That's this one, isn't it?
Oh.
That's y is equal to 2 to the negative x minus 3. I've drawn it. We drew a sketch.
Oh, so it'll be, the range would be negative 3 to infinity.
No, x can be any number.
No, he said the range. He said the range. He was talking about range.